In this video, we demonstrate an example of basic text output using the FileWriter class. The example illustrates that input-output must take into account the potential for checked exceptions to arise and shows how this is done. We show solutions that are compatible with exception handling in versions of Java prior to version 7 and from version 7 onwards. This example uses the Zool Beta project from an earlier chapter within the context of one of the exercises from this chapter. The exercise is to record a user's commands within a session of the game of Zool. Several possible approaches are suggested in the exercise. The approach we have chosen is to add a toString method in the command class. The game object has a list into which each command is saved. Each command is stored in the list immediately after it has been read. A new save command has been added that takes a second word naming the file the commands are to be written to. The save method currently just makes sure that a file name has been given. In this video we shall complete the method. We shall first use the style compatible with versions of Java prior to version 7 and then give a Java 7 version. To write a text file we need a FileWriter object. This is defined in the java.io package, so we shall need to import java.io to the game class. Let's create a FileWriter as if we know nothing about exceptions and see what the compiler tells us. The FileWriter's constructor takes the file to be opened as a parameter. If we wish to append to an existing file, then there is a second constructor for that purpose. The error message we see is unreported exception java.io.io exception must be caught or declared to be thrown. This is the standard error given when a checked exception must be dealt with in some way. The alternatives suggested in the message mean, in effect, either a try statement must be used here, or the current method must propagate the exception by adding a throws clause to its header. The latter option is rarely the right one in situations such as this, because it simply pushes the handling requirement back one level in the calling sequence and will elicit a similar error there. We can illustrate this by doing the wrong thing and adding throws IO exception to the header of the save method. When we compile, the result is exactly the same error, but at the point where the save method was called. So let's delete the throws clause and see how to deal with the exception back in the save method. Of course, what is awkward about exceptions is that the likelihood of their arising is often very remote. Here, for instance, there's probably little chance that we won't be able to write to the file, and the whole process can seem like a nuisance. However, there isn't actually that much overhead involved in writing an exception handler, so let's see how to do that. Firstly, let's write the full statement. The creation of the FileWriter will now be enclosed within a try block. Then we have to provide a catch block for the IO exception that might be thrown. While we might consider it unlikely that the catch block will ever be executed, we should not be tempted to leave it empty. That is just asking for trouble, and it requires very little effort to include a diagnostic error message. While we might not know the exact reason for the failure, reporting the fact of failure should be considered essential. Now we need to go back to the try block. Essentially, from this point onwards, we have to regard the viability of the rest of the method as being dependent on being able to open the file. Therefore, everything we write now should be inside the try block. If we include any statements after the full try statement, then they must be plausible for both the cases of success and failure. Such situations are relatively rare. Having succeeded in opening the file, the rest of the logic here is relatively simple. We need to iterate over the collection of commands, writing each in turn. Note that we separately write a new line character after each command string, because this is not included by the command object. Finally, we must close the writer to ensure that all the data is properly written to the file system and system resources are freed. It's worth pointing out that, as well as FileWriter's constructor, both the write methods and the close methods throw IO exceptions. All are protected by the same try statement. However, this does mean that the single catch block cannot distinguish between those four potential reasons for the exception arising. In practice, this does not matter much in this case, but it would make a difference if we wanted to be more specific with the error message. For instance, if we wanted to say whether the file could not be opened or a write could not be completed. Let's try out the save command in practice. If we look in the folder of the game, we see the file and can verify that the script was saved. We ought to try to induce an exception just to reassure ourselves that it is handled properly. Let's try saving the script to a location that we know does not exist. We see the error message we provided, which is reassuring. Finally, we show this alternative version of the save method. This has been written using the try with resource form of the try statement that was introduced in Java 7. Note that the creation of the file writer is done in the parenthesized section immediately after the try keyword. The file writer object is the resource. Notice too that there is no explicit close of the file writer. Resources are closed automatically at the end of the try with resource statement. Otherwise, the two versions are equivalent. In this video, we've written an example of basic text output using the FileWriter class. We've seen how the compiler informs us of the need to deal with a possible exception, and how to write a full try statement. There are further examples in the chapter.